All right, let's try to understand what is typecasting, what is the need of typecasting, and how to do typecasting in C programming. Here I have declared few variables, and of course you know what I'm doing here. So let's try to understand why do you need typecasting first of all. Again, here I'm going to go to the drawing so that I can explain you why we need typecasting. Let me go all the way down here. And let's say if we declare here, let's say one value 10, and if we want to divide this 10 with 4, so in this case, what you are expecting, you're expecting the result to be 2 point something, right? So you want the floating point value here, right? So let's do that. We have the value 10 and 4. If we divide this 10 with 4, let's see what happened. So here I'm going to say result equal or assignment operator, and then we're going to say number 1 divided by number 2. And of course, we know what is our expectation here. So let's say printf, and then we want to say result, and then let's say print the result here, %d new line, because it's an integer variable that we want to print. That's why we're using %d, and here I'm going to give result. Okay, that's all. And let's see what will be the output of this program. Okay, so here I'm going to run this program, and let's see what is the output. Again, let's be real quick here. I'm going to run, and it's building. So we have a result 2, but we expected 2 point something, right? We expected 2.5. So in this case, you might be thinking, okay, because we have integer variable, that's why it's holding only the integer value. Well, that's a good point. Here I'm going to change into float. And then in this case, if you want to print out the variable float, then you need %f, right? So probably you're thinking, okay, that should be all. And let's run it again. Let's see what it's going to do this time. If I run this program again, and then you can see the result is 2 point, then we have 0.0000. There are 6 decimal point, but still we are not getting exactly what we are looking for. Now, what is the problem here? The problem is, first thing we already fixed, in order to store the floating point value, we need floating variable. And this is something we have already fixed. So we have float result. Also, we are using the right format specifier, which is %f here, right? But we are still not getting the right value. And the problem is when you divide an integer number with another integer number, the value will be always, the output will be always integer number. If you divide a floating point number with a floating point number, the value or the output will be always in floating point number. So what basically we need to do here, I'm going to write again, just for your understanding. If you divide an integer number, here, let me just show you. So if you divide an integer number with another integer number, the output will be always integer number. Okay, but if you divide a floating point number with integer number, the output will be a floating point number. Or if you deal with something like this, integer divided float, the output will be float. So what basically I'm trying to explain to you, if there is at least one floating value, then the output will be floating point here. Now, if you divide something, let's say something like this, if you do something like this integer, then if you have double, just for an example. So of course, here the double is a floating point value as well. So the floating output will be the floating point or the double value here, okay? And why is that? Because if you have a look here, just let me explain you real quick. Just real quick, let's say 2.5. So in this value, you have the integer part, also you have the floating point part. So who can store this value? Let's say float can store this value. Float has the capability, or the double type variable has the capability to store the integer part and also the fraction part. On the other hand, integer type of variable doesn't have the capability to store these fraction part or the floating point part, right? So that's why whenever you want to get the floating point value inside a variable, remember to use float or double or something that can deal with only floating point numbers or fractional numbers. So let's go into our code again. So what we need to do, we need to do typecasting, because integer divided by integer, the result will be always integer. So if somehow we can make one of these variable float or double, the result will be in the floating point number. In this case, we're not going to go to the double value. We're still, sticking to our floating point value. So how can we make this integer variable into floating point number? How can we make this one even to floating point? If we can make any one of them to the floating point variable, then we'll get the expected result. And this is quite easy. If you want to do typecasting, that means you are converting one data type to another, then you have to use these parentheses, and inside the parentheses you can say what is the data type you want to convert to. So I want to convert to float. That's all I need to do. So what is happening here, the number one was integer data type, but just here we are converting the number one integer type to floating type, and that should give our expected result. So if I run this code again, let's see, this time we're getting the expected result, which is 2.5, right? And of course there are some default values there, 000. So in floating point variable, floating point variable can store 6 decimal points, and that's why you can see there are 6. So even after 5 there are 5 zeros there unnecessary. Now you know how to deal with this. If you want to keep only two values after the decimal point, then you can use point to f. So basically what you are saying, after the decimal point here, I want to have 2 places. That's all. So if I run this code again, you will see the result. So let's do it real quick. And this time you're getting 2.50. Now if I use here 0.1f, you know what basically it's going to do. Let me run it again, and here let me run and build it again, and this time you can see result 2.5. So hopefully things are making sense to you. Now again, if you do not want to do typecasting here, of course you could do it here. So in this case you could say float, and if you run it again you will see the exactly same result. So I'm going to run, and there you go, it's 2.5. Now there is one more example I want to give you. Let's say if you want to divide this number 1 with 3, you can do that. And now if you run this program, what do you think what will be the output here? So you have number 1, which is 10, the integer value here 10. You are dividing 10 with an integer value 3. So when you divide an integer number with an integer number, the result will be always integer number. So somehow, if you want to get the floating point value, you need to convert one of these values into floating number, right? So what you could do here, you could say 3.0, and this will give you the expected result. So let me run and let me show you, and there you go, you can see the result. But let's say if you don't want to do it here, you can change the data type of this number 1, which is basically integer. You can change this one into floating point, and this is what we call typecasting. And now we'll get the expected result, exactly same result, and there you go, you can see 3.3 there. So hopefully you got the concept of typecasting. Later on we'll explain it more. You will see more different kind of typecasting later on, but for now at least you know how to convert one data type to another here.